The battlefields of the 21st century have shifted dramatically. Once dominated by the thunder of tanks and the roar of fighter jets, today's conflicts are evolving into something far less visible, but no less deadly. The new front line is an invisible war, fought within the electromagnetic spectrum, a realm where battles are waged with signals, frequencies, and data, rather than traditional firepower. This is the era of electronic warfare, where the outcome of a conflict can hinge on who controls the flow of information. Here, signals, not bullets, are the deciding factor in victory or defeat. Every modern military system, from precision-guided missiles to encrypted radios and satellite communications, depends on this unseen network. The reliability of these systems can mean the difference between mission success and catastrophic failure. Mastery of the spectrum allows militaries to control information, blind their adversaries, and shield their own operations from prying eyes. It's about jamming enemy signals, intercepting communications, and protecting your own. Imagine an army suddenly rendered deaf and blind, drones plummet from the sky, GPS navigation fails, and entire units are cut off as communications go dark. The chaos is immediate and overwhelming. This is the devastating power of electronic warfare. What was once the stuff of science fiction is now a reality that militaries around the world are urgently preparing for, training soldiers and developing new tactics to survive in this hostile environment. Disrupting, denying, and deceiving enemy electronics has become as crucial to modern warfare as achieving air or naval superiority. The ability to outmaneuver an opponent in the spectrum can decide the fate of entire battles. Around the globe, nations are racing to develop smarter, faster, and more adaptable electronic warfare systems. The competition is fierce, with each side striving for an edge in this high-tech arms race. The ultimate goal is spectrum dominance, the power to see everything, disrupt anything, and remain completely undetected. Whoever achieves this will hold a decisive advantage in any conflict. In this high-stakes arena, China has reportedly developed a groundbreaking new system that could redefine the rules of engagement and shift the balance of power. Known as StormEye, this advanced technology represents a bold leap forward in the quest for electronic supremacy, promising capabilities that were once thought impossible. The silent battlefield, where invisible forces clash and decisions are made in milliseconds, may be where the wars of the future are won or lost, long before the first shot is ever fired. China's new weapon, StormEye, fires no projectiles. It controls the electromagnetic spectrum. Like the calm center of a typhoon, StormEye creates a protected bubble for PLA forces. Inside, friendly communications and navigation are safe. Outside, chaos reigns as enemy systems are disrupted. This leap in capability signals China's rapid progress in electronic warfare. StormEye is both shield and sword. It can jam, deceive, and protect with precision. Developed by Chinese scientists, it's designed to identify and target enemy signals while sparing friendly ones. This precision marks a shift from crude jamming to sophisticated spectrum control. By selectively controlling the flow of data, China aims to turn its opponent's strengths into vulnerabilities. StormEye is more than hardware, it's a strategic concept for future battlefields. It prioritizes control and precision, potentially changing the dynamics of any confrontation. The world is watching as this system redefines electronic combat. How does StormEye work? What makes it so effective at shielding troops and technology on the modern battlefield? At its core, StormEye is a sophisticated network of drones, sensors, and transmitters, all working together seamlessly. Swarms of drones constantly scan the airwaves, mapping the electromagnetic environment in real time, searching for any sign of enemy activity or interference. These drones can distinguish between friendly, civilian, and hostile signals, creating a detailed digital map of the entire spectrum around them. Guided by advanced AI, the drones transmit targeted signals to disrupt enemy frequencies, hijacking hostile drones, jamming enemy radios, and even blinding surveillance systems. The real genius lies in the bubble they create. Some drones go on the offensive, attacking enemy electronics, while others focus on protecting friendly forces. Using sophisticated interference techniques, they cancel out enemy jamming attempts and amplify friendly communications, ensuring clear lines of command. This creates a moving eye of the storm, a calm, protected center where PLA forces can operate securely, even in the midst of electronic chaos. The protective bubble adapts as the battle shifts, moving with convoys and shielding troops and critical systems wherever they go. If a new threat appears, the network can reconfigure itself in seconds, instantly shifting resources to counter the danger. The result is a mobile, intelligent electronic shield that moves with the force, always adapting to new threats and changing conditions. Friendly forces maintain command and control, communicating clearly, while the enemy is left in digital darkness, unable to coordinate or respond. Stormeye gives the PLA a private, secure slice of the spectrum, protecting their operations from prying eyes and hostile interference. It's a dynamic defense, not a static one, constantly evolving, always one step ahead of the enemy's next move. Stormeye's true innovation is its surgical precision. Unlike old jammers that blocked everything, Stormeye targets only enemy signals. Its AI maps the spectrum in real time, distinguishing friend from foe with remarkable accuracy. It can jam an enemy radar without touching nearby friendly communications. This selectivity is a game changer, enabling aggressive electronic warfare without self-inflicted damage. The system manages signals, allowing some through while blocking others. For example, it could let civilian GPS work while blocking military GPS for adversaries. This smart shield gives commanders unprecedented control. Stormeye learns and adapts, shifting tactics as enemies change frequencies. The system's cognitive warfare capabilities make it a dynamic, formidable opponent. It's not just programmed, it thinks, reacts, and evolves. This is what sets Stormeye apart on the electronic battlefield. For decades, Western nations dominated the field of electronic warfare, relying on brute force jamming techniques and sheer technological might to maintain their edge on the battlefield. Powerful platforms like the US Navy's Growler aircraft became the gold standard, setting benchmarks for electronic attack and defense capabilities across the globe. But these systems depended heavily on overwhelming power and size, focusing on saturating enemy sensors with noise and disruption. Now, a new approach is emerging. Stormeye represents a radical shift in philosophy, one that emphasizes finesse, advanced networking, and intelligent, adaptive control. Rather than relying on a handful of large, vulnerable assets, Stormeye deploys swarms of small, resilient drones that can operate together as a coordinated force. If a few drones are lost in action, the network instantly adapts, reconfiguring itself to continue the mission without missing a beat. Unlike older Western systems, which were often specialized for either attack or defense, Stormeye is designed to do both at once, simultaneously shielding friendly forces and striking at enemy systems. This seamless integration marks a significant technological leap forward. At the heart of Stormeye is artificial intelligence, enabling the system to analyze vast amounts of battlefield data and make split-second decisions far faster than any human operator could hope to achieve. The pace of electronic warfare is now so rapid that only AI can keep up. A system that can think, learn, and adapt on its own has the potential to dominate future high-tech conflicts, changing the very nature of warfare. If China has truly mastered this new paradigm, it could unlock an unprecedented level of operational freedom. The global balance of power in electronic warfare may be on the verge of a dramatic shift. Stormeye is just one piece of China's broader strategy for information dominance. Beijing sees spectrum control as central to winning future wars against advanced adversaries. This strategy spans military hardware, civilian telecom, and AI, all fused for information supremacy. China's new electronic warfare jets, ground stations, and naval assets form a multi-layered network. Civilian advances in 5G and 6G provide the backbone for military applications, enabling massive drone swarms and real-time data processing. Military-civil fusion accelerates progress, turning commercial breakthroughs into battlefield advantages. AI is the glue, directing swarms, analyzing the spectrum, and making split-second decisions. By combining hardware, networks, and AI, China is building a formidable electronic warfare ecosystem. Stormeye is a key but not the only part of this ambitious puzzle. Despite bold claims, Stormeye remains unproven in real combat. So far, its success is limited to computer simulations, not the chaos of real battlefields. Coordinating drone swarms in contested environments is a massive engineering challenge. Maintaining secure high-bandwidth links under enemy jamming is tough. Power, endurance, and cost are real concerns. Thousands of drones and complex infrastructure add up. China's military budget is big but not limitless, and past projects have faced delays and overruns. Details come from academic papers, which may exaggerate for strategic effect. Until Stormeye is tested in real exercises or conflict, its true power is uncertain. For now, it's a concept, impressive, but not yet a battlefield reality. The US and its allies aren't standing still, they're racing to counter systems like Stormi. The Pentagon is investing in AI, machine learning, and distributed spectrum management. The focused, resilient communications and navigation that work even under heavy jamming. Techniques like frequency hopping and beam forming make it harder for Stormi to disrupt signals. The US is developing its own cognitive electronic warfare, setting the stage for a battle of algorithms. Counter-swarm tech is key high-powered microwaves, hunter-killer drones, and electronic attacks to disrupt or hijack enemy swarms. DARPA is leading efforts to defeat large autonomous drone networks. The West's doctrine, Joint All-Domain Command and Control, aims to connect every sensor and shooter into a seamless network. This is the Western answer to China's informationized warfare. The race is on to build the most robust, intelligent, and resilient networks. Stormi's emergence is accelerating this high-tech arms race. Will Stormi truly change the future of war? The answer is complex. The shift to precise networked spectrum control is a major evolution in military thinking. If fielded at scale, Stormi could give China a formidable edge, challenging Western dominance. But technology alone doesn't win wars. Training, integration, and reliability matter. Its impact will depend on countermeasures and the relentless cycle of innovation. Stormi is best seen as a symbol of China's rise as a military innovator. The electromagnetic spectrum is now a critical, contested domain. The stakes are high. Dominance here could decide future conflicts. The world is entering a new era of high-tech military competition. The storm is gathering, and the race for electronic supremacy is far from over.